think we were right here. All right, so I was talking about the difference between a solar day, which is of course 24 hours. It's defined as 24 hours. That's the time from noon to noon, right? So from the noon of one day to noon of the next day. That's a 24-hour period. But it turns out that because the Earth is going around the sun, in its motion around the sun, it has moved, one day further around the sun, and therefore the time that it takes the Earth to spin around, like if you were to look at a particular star and then wait for that star to appear in that telescope again, like you didn't move the telescope, you kept it exactly still, and you waited. It doesn't take quite 24 hours to line up again, because of course the Earth is moving around the sun. So it takes a little less time. It's about 23 hours. Let me see if I remember it. It's about 23 hours and 56 minutes and 4 point something seconds. Is like really, really short amount of seconds. So 23 hours, 56 minutes, and a little more, just slightly more than 4 seconds. It's almost full. But so because the sidereal day and the solar day do not line up, right? That's exactly why there are not perfectly 365 days in a year, right? It's really 365 point. It's like 0.24 something. So it's almost 365 and 1/4 day, right? And of course the way that the calendar, the Gregorian calendar, has adjusted for that is that every 4 years, of course, we add 1 day to February, right? So that kind of takes care of the problem, but not quite. And so we nowadays, in modern times, we have to use what are called leap seconds, right at midnight on December 21st. December 31st. We either add or take away a certain number of seconds so that the Gregorian calendar is correct. All right, so let's see. So one of the things that we notice, remember this chapter is about what ancient peoples saw, is that if you look, for example, in the night sky in the summertime in the northern hemisphere, you will see Scorpio and Sagittarius and Capricorn, and of course Aquarius is just to the left. But if you sit there and let's say you see Scorpio and it's I don't know, let's say it's July or something like that, and you wait, and so you go out and Scorpio is really close to the horizon. You go out night after night. Now the Scorpio won't appear to move very much, but right after sunset, you see the entire constellation of Scorpio, which is actually a really large constellation. But you wait, night after night, you go out, you watch, and the bottom of Scorpio. So let's say it gets dark out, and several weeks have gone by since you started looking, and you could see, initially you could see the entire constellation of Scorpio, but you'll notice after a few weeks, the bottom of Scorpio, when it gets dark, will be below the horizon, and then as you watch longer and longer and longer, eventually Antares, which is the brightest star in Scorpio, it's a very bright kind of orangish, reddish star. It's kind of the eye, what they call the eye of the scorpion, will dip below the horizon as well, and so then you'll on that same time, right after sunset, you'll see Sagittarius, and eventually Sagittarius will dip below the horizon, and so forth, right? It just keeps doing this, and then you find that you're no longer in summer, right? You'll see the fall, the fall constellations. You can see most of the constellations, by the way, if you wait long enough in the night at nighttime. The only constellations that you can't see are the ones that the sun is in. So these constellations, which the sun goes through, are called the constellations of the zodiac, of course, and they're the familiar ones, as we know, Taurus and Gemini and Leo. And Leo and Cancer and things like that. So those are the constellations of the zodiac. But you don't. When the sun is in one of those particular constellations, you're not going to be able to see that constellation, or really the one right before it. That is right to the right of it, or just to the left of it, right behind it. Because the sun is so bright, and you won't exactly be able to see that. But that's actually what when we talk about. When we talk about it, but when astrologers talk about, the sun, the sun is in the constellation like Sagittarius or something like that. Generally, that happens let me think about it for just a second. So when the sun is in the constellation Sagittarius, that happens in the winter time in the northern hemisphere, of course. And that's actually when the sun is lowest in the sky. And that's because it's in Sagittarius. So, like, if you looked at all the constellations of the zodiac, it looks kind of like a sine wave. Like in math, you have this sine wave that kind of goes up and then dips down and then goes and it just kind of repeats, right? And that's really the constellations of the zodiac. The reason that they go up and down if you were to map out the whole sky, is really the tilt of the Earth. The Earth is tilted by about 23.5 degrees, and so this bottom, where Sagittarius is the bottom of the sine wave, and then the top of the sine wave is the constellation Gemini. Right, Gemini is when the sun is in Gemini. That's when it's the highest in the sky in the northern hemisphere. So that's like, for example, when the sun is in Gemini, that would be the first day of summer. When the sun is in Sagittarius, that's the first day of winter, right? Usually, so in summer, that's usually around June 21st. Not exactly June 21st, but really close to there. Sometimes a day or so before, or a day or so after, because of course the year is not exactly 365 days. And the same thing goes for when the sun is in Sagittarius, right? When the sun is in Sagittarius, and if you happen to be in the northern hemisphere, that's when the sun is the lowest in the sky. Of course, if you're in the southern hemisphere, that's when the sun is the highest in the sky. But anyhow, for the northern hemisphere, that's the first day of winter, right around December 21st. Sometimes a little bit before, sometimes a little bit after, for the same reason that the year is not exactly 365 days. All right, so here's all 12 of them. And it's showing, as the Earth goes around the sun, of course the sun is going to appear in these different constellations. Again, we don't see the sun in those constellations because, of course, the sun is so bright. But we know that the sun is in the constellations. You can just reason that out. And of course, remember the modern times. In modern times, the vernal equinox, the spring equinox, occurs in Pisces when the sun is in Pisces. Back in the time of the Greeks, the sun was in the constellation Aries for the first day of spring. And like I said, in about roughly 700 years or so, 700 to 800 years, the sun will be in the constellation Aquarius, right? That's because of the wobble of the sun, the wobble of the Earth, and then and it keeps going, right? That wobble takes 26,000 years to complete itself. So the spring equinox will occur in in all the different constellations of the zodiac over a 26,000 year period. All right, so you might ask, for example, a very common question to ask, even high school students or even elementary school students or college students even, and a lot of people get this wrong at first. You ask, why is it hot in the summer and cold in the winter? And it really has to do with the angle of the sunlight on the surface of the Earth. So because the Earth is tilted, that tilt stays in the same direction. That's exactly why, for example, in the northern hemisphere you can always see the North Star, right? Because it lines up with the North geographic pole, projected out into space. But that stays in the same orientation. Doesn't matter what time of year, so it always stays in the same orientation. That wobble that I was talking about is very, very slow. You don't see that in one lifetime. You hardly notice that at all. But it's all in the same. It's still there. But just assume for the most part during one human lifetime, the Earth is always pointed. The North Celestial Pole is pointed at the same point in space. So because of that, during when the northern hemisphere is tilted towards the sun, that's the first day of summer. When it's 6 months later tilted away from the sun, that's the first day of winter in the northern hemisphere, and of course that would be the first day of summer in the southern hemisphere. Right? So that's this shows it really well. If you look at how the light comes in, you have, like, let's say a given area of the Earth's surface is receiving more direct sunlight, and then 6 months later that same area on the surface of the Earth gets sunlight at a much greater angle, and so that light is spread out, and it's a lot cooler in winter. All right. So that explains the seasons. Of course, we have the two equinoxes. And by the way, the same reason that there's more daylight, during the summertime, and more nighttime in the wintertime. For that same reason, halfway between those, between the solstices, are what are called the equinoxes. So let's start in the winter, right? You get the shortest amount of daytime. And what I mean by that is the time that it's dark, right? The day is always the same amount of time, right? The solar day is always 24 hours, but the amount of light that you get, of course, depends on your latitude. If the closer you are to the North Pole, on December 21st, if you're above what's called the Arctic Circle, a point 23.5 degrees from the North geographic pole, that's of course called the Arctic Circle. It's completely dark during that time, and can be for several months depending on how close you are to the North Pole. But if you're right at about just under 23.5 degrees, let's say 24 degrees, is your latitude. Is your latitude. Then